We're tackling Newton's laws and the critical skill of drawing free body diagrams, a topic guaranteed to appear on your FE exam, regardless of your discipline. An incorrect free body diagram is one of the most frequent reasons for wrong answers in the statics section. Let's start with Newton's first law, which is the foundation for all statics problems. An object in equilibrium, meaning it's at rest or moving with a constant velocity, has no net external force acting on it. This simple principle is what allows us to write our equilibrium equations. The most crucial skill, and where most points are won or lost, is the free body diagram, or FBD. Mastering the FBD is the first and most important step in solving almost any equilibrium problem. You must isolate the body from all its surroundings and draw every single external force acting on it. This includes applied loads, the object's weight acting at its center of gravity, and, critically, the reaction forces from supports that you have conceptually removed. A huge exam trap is misinterpreting these supports. For the FE exam, you must know that a roller support provides one reaction force perpendicular to the surface. A pin support provides two reaction forces, typically in the X and Y directions, and a fixed support provides two forces and a reaction moment. Once your FBD is perfect, for a 2D statics problem, you apply the three equations of equilibrium found in the NCEES FE reference handbook. The sum of forces in the X direction equals 0. The sum of forces in the Y direction equals 0. And the sum of moments about any point equals 0. A pro tip for the exam is to sum moments about a point where the most unknown forces act, as this simplifies your algebra by eliminating those forces from the moment equation. Now, for dynamics problems, we use Newton's second law. The sum of forces equals mass times acceleration. The FBD is still your starting point, but now the net force is not 0. The exam will test this with problems like accelerating blocks on an incline or systems with pulleys. Finally, Newton's third law, stating that for every action there's an equal and opposite reaction, is key for problems with multiple connected bodies. When you separate two bodies for their FBDs, you may label them FBDs. The force body A exerts on body B is equal and opposite to the force body B exerts on body A. A common mistake is getting the direction of these internal forces wrong when analyzing a complex frame or machine. To keep it all straight on exam day, use this mental shortcut, IARE. First, isolate the body. Then, draw all external forces, including applied loads and reactions. Establish your axes. Finally, write the equilibrium equations. For free practice questions, AI-powered explanations, and more exam prep tools, visit openexamprep.com. That's openexamprep, all one word, .com.